In this video, we are going to talk about line integrals. The question we want to answer is this. Given a curve C on the xy plane, what is the area under the surface z equals f of xy on top of the curve C? Let's try to draw a picture to see what we're interested in. First, let me draw my coordinate axis. I have my x, y, and z axis. Then I have a surface defined by z equals f of xy. Next, I have some curve C on the xy plane. If I take each of those points on the curve and plug it into my function z equals f of xy and plot all of those points, it's going to trace out a curve on the surface. So what we're interested in is the area under the curve on the surface above the xy plane. To calculate the area of this region, we're going to set up a Riemann sum. Our first step is to divide the curve C into n pieces, each with equal arc length, delta s. Next, we're going to approximate the area under the curve on each segment. For example, on the segment from xi yi to xi plus 1 yi plus 1, we have the following shape. To approximate the area, I'm going to assume that the height is constant throughout. We're going to take the height to be the height at one of the endpoints, f of xi yi. To get a better picture, let's take this segment and flatten it out. Since we're approximating the area with a constant height of f of xi yi, the shape is now a rectangle, which we can calculate the area using the base times the height is f of xi yi, and the base is delta s. So the area on this segment is approximately f of xi yi times delta s. Next, we want to approximate the area over the entire curve by adding up the approximate areas on each segment. So the total area is approximately the sum from I equals 0 to n minus 1 of f of xi yi delta s. Notice that if we divide up our curve C into smaller and smaller pieces, our approximation is going to get more and more accurate. So in our last step, we're going to take the limit as delta s goes to 0 to get the exact area. So our area is equal to the limit as delta s goes to 0 of the sum from I equals 0 to n minus 1 of f of xi yi delta s. And we denote this limit as the integral over c of f of xy ds. And that's what we call the line integral of f over c. In our next video, we'll talk about how we actually compute line integrals and do some examples.